Do you recall the time value of money? I hope so. We're going to do just a very quick review here. And the idea is that there's a gap between the time of when you receive the benefits from when you lay out the costs. And this is typical for an investment. So we use the tool of present value analysis to make sure that we consider the time value of money. And we have a couple of analyses that we're going to look at. First is what's the present value of a single payment? This formula should look familiar to you. Is present value equals the future value divided by 1 plus the interest rate raised to the period of time. And the other consideration that we're talking about here is what are the cost of waiting? This is essentially what is the alternative that you have. When we look at the present value of a stream of values, this again should look familiar. We take each of the future values for time 1, 2, 3, all the way till the last cash flow that we have, divided by 1 plus the interest rate raised to the power of time. And that's signified by the expression below. The net present value also considers what is the cost of the investment upfront. That's why we have cost at time 0 out there highlighted in yellow on the far right. So we take the present value of the cash flow stream, and then we subtract from that the investment. And if the result is a positive number, it's a good NPV because it yields more than the required return. If it's negative, it doesn't mean that it loses money. It just means that it doesn't earn sufficient money to cover the cost of time. In other words, the required return on that investment. So let's try an exercise to exercise some old muscles. And we're going to have a very simple one. A project would cost us $120,000 and returns the following estimated returns. Year 1, 10,000, year 2, 50, year 3, 100, and the interest rate is 8%. And the question, you know it's coming, is should you say yes or no to this opportunity? So let's switch over to Excel and we'll do this math together. Again, it should be pretty much a review. Here we have the problem on the left and the structure on the right just to facilitate. So we have the rate of return, 8%. We have the time frame from time 0 out to time 3. We've input the relevant cash flows that relate to each of those. So first thing, let's do the present value of the cash flows equals NPV, open parens. The rate is there, point to it, comma. Then the values, just shade from T1 forward. Again, remember, don't go to T0. And that gets us an NPV of 131. The outflow is 120. And the NPV then is a positive 11,509. So this would be, it meets our requirements. So it's a good project. So in this case, absent other more attractive alternatives, we would accept this project. So I hope this sounds very familiar because it should be, because we studied it just a few weeks ago. Next, let's look at a different scenario where we have no endpoint, that it's out to infinity. So it's an indefinite cash flow stream. And this also may look a little familiar. This is called a perpetuity. And in this case, we have a cash flow at time 0 and then time 1, 2, 3, etc. But now it doesn't end. It goes all the way to infinity. And if there's no growth, then notice that CF0 is equal to CF1, CF2, etc. There is no distinction. And in this very specific case, we call it a no growth perpetuity. The present value of this is simply the cash flow, and they're all identical, divided by the rate of interest. But what if the perpetuity has a constant growth rate, not 0? In this case, the form is a little different because we have the present value of the firm is now the free cash flow from time 0 plus time 1, time 2, time 3. However, it grows by 1 plus the long-term growth rate of G based on the number of years outstanding. So now there's a slight adjustment to the perpetuity formula for this, again, specific case of constant growth. And it equals free cash flow for time 0 times parens 1 plus the growth rate. That gets us out to a free cash flow year 1 term divided by the interest rate minus the long-term growth rate. So this is something, again, we've seen before. The format we saw before was FCF sub 1 for time 1. This is a slightly different format because it shows that we start with free cash flow for time 0. We grow that by 1 year and then take that result divided by I minus G. So exactly the same. It just starts at a different beginning point of free cash flow from time 0 rather than from time 1.